Hi, I'm Wally from Energy Web, and I'm here with Mark from Biogas SA. And today we're here in Katlehong by Manzini Primary School, where we're installing one of Mark's biogas bag digesters. In our previous videos, you've seen Mark giving us a bit of background on biogas in South Africa and the theory behind the biogas digesters. In this video, Mark is going to give us some of the technical considerations when considering to install a biogas digester and the factors that you need to consider. And we're going to show you how we're going to start with this project and what's involved in the digging of the trench and the construction of the biogas trench. Mark, give us a bit more information.
Yeah, morning, Wally. Thank you very much. Yeah, what is nice about the installation here at Katlehong at the primary school is the fact that we're going to primarily use their waste from their kitchen, from their soup kitchen, as the primary feedstock. We're not going to connect it to the sewage system, so we're purely going to use the organic waste coming from the kitchen. And the big advantage there is you don't have to be so careful about gravity fed in and out as you would be if you're going to connect it to your sewage system. That's the one advantage, but the other advantage as well is that the digestate or the effluent that comes out of the digester is devoid of any of the really bad pathogens that you normally would find in human waste. And that is a big advantage here at the school, because part of this whole project is that they've got a food garden here where they grow vegetables for the kids. So it's part of the program. So the digestate that comes out of the digester is a very good organic compost. And because it's then free of pathogens, we can, without any trouble, use that directly onto the vegetables. So that's the main advantage of the system that we've got here. The way that we work it's a very simple. We're installing here the bio bag digester. You've got many different types of digesters. You got the fixed dome, you got the brick and mortar one, you got the in situ cast concrete one, you got the plastic rotor molder units. What we're using here is literally a PVC cylindrical balloon. And
if I may, Mark, just if you're interested in some of the information on the other digesters, that's in the other video that we've also posted, that you can see where Mark has gone into a bit more detail on these digesters and what has been done in South Africa.
Yeah, so basically what we're going to concentrate in this video is just the physical installation of the bio bag itself. The different components made up, the way that this thing is constructed is you've got an inlet manhole, and you got an outlet manhole, and then you got your main digester in between. And the main reason for that is you've got basically a three-chamber system. And the main reason for that is that your material that comes into your digester has got to go into your main anaerobic part of your digester and ensure in the process that there's no oxygen getting into your main digester, and hence the three compartments. So what you will do, you will feed, all your feedstock will go into your inlet, not into your main digester, and that will then below the water level be pushed into your main digester, and in that process you're ensuring the anaerobic conditions in your main digester itself. So as the material then systematically moves and progresses through your digester, by the time it gets pushed out into your outlet again, then you've got 30 days have gone by and the whole digestion process has taken place. And in the top part of the digester, you will capture your biogas. So that's really a very, very simple story. If you can imagine, you've got a cylinder that's always 2/3 full of liquid, and it's maintained at that level. So the top third of your bag can get inflated as the biogas gets produced. So you simply got a tap-off point at the top of your bag that then feeds the gas into the kitchen, where we will then install a biogas stove that the staff then can use to prepare the food for the kids.
Mark, I would imagine maintaining that, you're mentioning a 2/3 level, water level in the that's got to do with how you install the digester and your water levels, I would imagine.
Absolutely. So your water level in your digester, in your entire system, will literally be maintained by the outlet level of the pipe in your outlet manhole. So that level will determine at what level you maintain the liquid level in your entire digester. The lower it is, the lower your liquid level will be and the more gas space you will have. So that's why that is probably the most important point when you're setting out the digester, especially when you want to connect it to the sewage system, that you make sure that that level then has got sufficient gradient going down if you want to connect it into your sewage system. But that outlet pipe out of your outlet manhole will
Determines the float of, or the level
exactly.
of the whole
Yeah,
system.
the easier way to explain that, if you imagine you've got a hose pipe, you know, in a U shape that's full of water, and if you then chuck a cup of water on this side, it's simply going to push a cup of water out on that side. So that's the basic principle that you maintain in order to do or use in order to maintain your water level in your digester. But that's the basic principle. It really is quite simple. So yeah, if you can imagine, you got you know, 2/3 of the level of your bag is liquid level at the bottom, and the top third is then where your gas accumulates.
Capacity is.
So you know, and that can go up and down.
Yes.
Depending on the usage of your gas, how much gas you use on a daily basis. If the school comes back after the weekend and it wasn't used on Saturday and Sunday, your bag will be standing full of gas, and then it'll be used again as you go along. You can have a small little gas pump to pump the gas out of the digester, or you can simply, in rural applications, what we simply do there, we take 2 old car tires and just place them on top of the bag, and that'll give you sufficient pressure to push the gas through your pipe into your point of application, your biogas stove or so on. So it's really quite a simple system.
Mark, I've got 2 questions for you for this installation. Number 1 is, how are you going to maintain the output level? So in other words, if the school does not remove the processed digestate, is that going to flood our area? That's the first question. And the second one, let's say for instance over a holiday period, if it produces a lot of gas, what happens? Will this thing explode? How do you manage the overproduction of gas with the
Two
system?
very valid and very good questions. As I mentioned, the answer to your first question is simply we will connect, in this instance, we will connect the outlet pipe to the existing sewage
so not
system.
incoming sewage, but outlet. Okay.
So the
that helps
outflow.
for the outflow.
Exactly. So
Okay.
in this case, we'll show that a bit later on in the video as we progress with the building of the digester. We're going to raise the whole level of the digester slightly so that we've got a sufficient a level so that the water can flow automatically out into their existing sewage system. So if they don't use a bucket to harvest the digestate to use on their vegetable gardens, it'll simply overflow into
Be lost into
the
municipal
you know,
system.
you don't use it, you lose it, unfortunately.
Yes.
And your second question regarding the pressure, obviously the biogas is not a switch that you can switch on and off.
Yes.
So if you know, it produces 24/7. Same as your stomach. Your stomach never stops digesting. It keeps on working. So the digester works on the same principle. So what happens is, if we've got a pressure relief valve, so if the pressure in the bag gets too high, it simply opens a valve and it vents. We will vent to comply with regulations. We will vent the methane higher than 2 meters off the ground. And the main reason for that is that methane is it's lighter than air. So if methane escapes to the atmosphere, it immediately goes up into the air. So that way you can fill a balloon with methane gas and it will go up into the air. Whereas LPG gas is a very heavy gas, and that will go sink down to the floor and accumulate on the floor. And that's what makes LPG gas particularly dangerous, because if it accumulates and lies on the floor and you drop a match, then you've got a flash explosion. Whereas methane, so we simply, in our outlet vent, we just put a pipe up that's 2 meters high. So when it does vent, that toxic gas will vent up into the air and immediately escape skywards. So you know, so it's a very, and also another factor, because people always ask, oh, gas is dangerous, it's explosive. Yes, one has got to take precautions, because methane is combustible, without a doubt. But because we haven't got the pressure that is present in LPG gas, the gas is compressed in a cylinder at X number of bars. If that explodes, it'll take your whole house with you. But we never have more than 0.02 bars or 0.03 bars of pressure in the bag. So it's not an explosive hazard. It's a combustible hazard, but not an explosive hazard.
Especially in a scenario like this with children and stuff, much safer.
Absolutely.
I think, Mark, for the viewers considering this as a potential project, can we have a look at the construction site and you just give us a little bit more detail?
Let's
on
go
the
through
size
that.
of it?
Absolutely.
Okay.